Hi everyone, this is Mundan Raghavan and today we are going to see the slope concept. In order to learn the gradient descent, it's essential to understand the slope concept. However, it's been a long time that we have learned the slope in our college days, but now this session we will understand the basic concept about the slope. So before starting slopes, we will just consider two triangles here. Consider these two triangles as hills. If you see the two hills, the both has the same height of 3 units, and one point it is having at the base it will be having 2 units, another one is 1. So by considering these two diagrams, you can easily identify which one is the steeper one, which one is very difficult to climb. By seeing this diagram, you can clearly understand this one will be very steeper, which is very difficult to climb. So how we are concluding that one? The ratio between the rise over run. So that means that this is your run and this is your rise. In our case, the rise will be same in both triangles, but however the run will be different. So if you make the ratio between the rise over run, here it gives 3 by 2, 1.5, and here 3 by 1 is 3. So that means that the ratio between the rise over run will decide which one has the steeper slope. The next point we will see here. In the graph, if you consider the straight lines, so let's consider this is a x point. From x point, and you are considering after some time it is changing to delta x. So that means there is an increment in the x, and the same way y also increasing from this point to this. That will be considered as a delta y. So if you consider this formula, the difference between the delta y and the delta x, or the ratio between the delta y and delta x, will give the average rate of change. That will be called as a slope. So in this case, since it's a straight line, the change or the slope will be delta y by delta x. And in every case, let's say x, after some time it changes to delta x, it is in the positive direction. The same way, the y, after some time it increases, so it is a delta y, it's in positive direction. So if you make the ratio between these two variables, that will give us a positive output, which means that the slope is positive. The same way, if you consider this one, after some time the x changes to delta x, but however the y, it's not increasing, it's decreasing. So that means that the y is decreasing. That's why the denominator will be negative. So it is becoming a negative slope. That means that the line is going downwards. In case of lines, this is easy, but in case of curves, it will be a little different. For example, in the curve, the slope will be changing in every point. So like straight line, you cannot consider the delta x and delta y, because every place the tangent line will be different. So for example, in this curve, if you put 3 points, and every point if you make the tangent line, so that will be having a different slopes, because this is a different slope and this is a different slope and this is a different slope. So how to identify or how to find the slope for this? Before this, just I will tell one thing. So let's say the straight line, finding the slope is easy, but however the curve is different. But if it touches at only one point, that will be the tangent. But however, if you zoom in very closer to that point, so you can identify in particular point the line and the, let's say, the curve will be having the same slope. That means that it almost equal to the straight line. The same concept we will understand further. But however, here before proceeding, I need to explain about the tangent and secant line. It's already explained in our college days, but just to recollect, tangent is the line which touches the curve in only one point, whereas secant is the line which cuts the curve in 2 points. So that will be the secant line. Now we will come to the actual equation or the actual diagram. Let's consider this is the graph and the function is fx is equal to y is equal to x squared. So that means that whenever you give some value, that will be squared in the y area. So if you consider this graph, so now we will write the tangent point. For example, we are just trying to find the current slope for this particular point x1. So we will draw a straight line. So finding the slope for the straight line is very easy, but however we need to find in the particular point of this x1. And we will draw the secant line, let's say 3 secant line, s1, s2, s3 respectively. Now x1 to s1, finding the slope will be easy, because that will be the same formula, delta x divided by delta y. But however, this slope is different and the point slope is different. So we need to find this point, right? So just consider this slope and this slope will be different categories, but however, just reduce the s1 to s2, then this slope and this slope will be almost near. Then reduce to s3, and this slope will be little near when compared to the s1 and s2. If you proceed further in the same way, for example, this is the x1 to delta x. So s1 cuts at the curve at point s1, and it will be considered as a delta x. The straight x equivalent will be the delta x here. So as soon as you reduce your secant line, so that will be reducing. So that means the delta is getting reduced slowly one by one, right? So at some point, if you keep on reducing, at one point, if delta x is very near to that x1, that means the delta x is very close to 0 but not actually 0. That time the curve and the, let's say, the curve secant line equation and the tangent line equation will be almost equal. Then the equation for the secant line will give you the slope of that particular point. So that means that in that particular point you will find the slope for that curve. So the same concept here we have seen, right? So in the dot, if you put at the tangent line, so in particular point it will be giving the slope. That means that the slope at this particular point for the straight line and the slope at the particular point of the curve will be same at particular point, which will be, that means that the delta x is very near to 0. That means that you will find this secant line is almost near to this point. But however, here main point is the delta x, that means that the reduction will very near to the 0 but not actually 0. So because if you make it a 0, that means that it's not a straight line only. That means that we are trying to reduce the delta x as much as very less than the 0, I mean very close to the 0. The same equation you can see as a, let's say, algebraic form here. So y is equal to x squared. So let's say x1 increases to delta x, that means that function also x1 plus delta x, in change in x will be increasing here, and the starting value you consider as a x1, then the change in x will be the delta x. Now you just make the equation. Now our equation is x squared, that means that the entire value will be taken square value and the x1 will be the square value, then a plus b whole square, so a squared plus b squared plus 2ab, that same concept will come. Then if you just cancel the x squareds and minus x squared, then you will have 2x1 delta x plus delta x squared divided by delta x. So in this equation again, if you take the delta x outside, so the delta x and delta x will be cancelled and 2x1 plus delta x. As we discussed earlier, the delta x will be very close to the 0 but never be a 0. So that's the reason if you consider very close to 0, just consider 0.00001 or something like more near to the 0. So that we will be, it is very negligible, so we can reduce that one and we can remove that. So that time it will come as a 2x1. So this is the equation for the x squared. For example, at any given point time, instantaneous time, so that time the change will be, or the slope will be 2x instead of having this whole equation. But here one question may arise, like delta x, if you apply 0 here, so it will be infinitive, because anything divided by 0 will be infinitive. So for that reason we will not apply the 0 here. And one more thing is, as we discussed, the delta x near to 0 but not 0 actually. So that's the reason we will not apply the delta x is equal to 0 here only. We will apply all the equation at the last point. We will consider this delta x very close to 0. That time also we are not making a 0. We are just ignoring or neglecting the delta x because it's very near to the 0. Because this is about the slope, and why we have seen the slope concept is like, for example, you might have seen the gradient descent. So the last function will be always the curve, and you need to find the slope, or you need to find the, let's say, tangent line for that. So every time it will be same. And in this side, if you see, this will be the negative slope, and if you see from this point, this will be the rising slope, and particular optimal point the slope will be 0. So to find the derivative for this one, for curve, we need to find at every point we need to find the slope. To understand that one only, we need to understand the slope concept, and we need to understand the derivative also here, because this derivative will give you the derivative point where the delta x is very minimal, that you can find actually the slope at particular point. Because as you see here, you cannot find directly slope for this straight line, or you cannot find directly slope for this straight line, because every point the tangent line is different and the slope will be different. In real time, we will not have any reaction like straight line, because in real time everything will be a continuous change and it will be like almost like a curve. For example, if you take a car also, let's say in the starting time the acceleration will be less, but after it will pick up the speed. It's not like in starting onwards you will pick up in the same speed. So this is all about slope. So thanks all.